Bismillahirrahmanirrahim. Okay, welcome everybody. Ready?
Yes.
Okay, thank you. So, welcome everybody to my class. This is the first class of it's called CS1. CS1 is called in some universities it's called Computer Programming 1, or it is some universities it is called Computer Science 1, or in some universities it is called uh, problem solving and computer programming 1. That means it is a very basic course and first course of computer programming. So in this course, so you will learn, okay, to improve your algorithmic thinking. Okay, so you will learn soon what is an algorithmic thinking. Actually, we will discuss that, and you will improve your algorithmic thinking with emphasis on pseudocode development. Pseudocode, that means is not an actual code, but it's kind of computer program code. Okay, so by the end of this class, you will learn within an hour. Definitely, this class will take an hour. Then, after an hour, it is expected that if you give attention, and then if you follow me, then you will learn what is an algorithm, what is called algorithmic thinking, and what is a pseudocode, and how to write an algorithm and how to write a pseudocode. If you understand these things, then this will be your startup problem solving with computer, that you will learn how computer works and how do we computer programmers start learning computer programs. Okay, so please follow me. So the topic we will start with what is a computer. So I believe everybody is here, you know what is a computer. Mahdi, can you please tell me what is a computer? Yes, loudly, please. Yes, tell me.
Use it to do stuff. Programs.
Okay, so you can share it with me after. What is a computer?
Computer has different kind of activities, like to calculate something, to type something, save some memories, save some data.
Okay, thank you. Munim, what is a computer? My question is very simple. What is a computer? Is it a device, or is it a vehicle, or is it an animal, or is it a human being? Something. What is a computer?
It's a cat that likes to run on data, and you can break it in its pieces. And one question: if it's so simple, why do you take it seriously?
Yes, because we will start from very simple. The good question. We will start from very like basic thing. Okay, so what is a computer? A computer is a machine, right? It's an electronic device. It's a machine, right? But it is so useful nowadays.
It's
the computer
3
is
o'clock.
so useful, is so popular, and so demandable, and so appreciable, and so powerful, right? A computer can execute a lot of things, right? Do you think that what is the reason of being popular and demandable? It's like this small device, like a computer as a device, why it is so popular, or why it is so powerful, and why it is so demandable?
It makes the work more easier.
Yes, that's the one thing. It makes the difficult work more easier and
Fast.
and correct, right? As a human being,
More accurate.
more accurate. As a human being, if we do some very simple thing, but for a long time, we become tired, right? We become tired. For instance, if I ask you to write 0 all the day long, is it able for? Will you be able to write zeros? Only 0 for whole day?
No.
No, it will be a great punishment for you, right? You cannot type, you cannot write or type even 0 whole day, because if you start writing 0 after a few minutes or after a few hours, your 0 will be something O or something another letter, something different, right? The reason is because as a human being we become tired, and for while, especially while doing same thing again and again, right, we lose our interest, right? But computer is such a machine that it does not become tired, okay, it does not lose its interest, right? So this is why if you ask a computer to show you same thing again and again and again whole day, it will show you that again and again and again for whole day and without making any mistake, right? Okay, so now do you know the reason why a computer does not do any mistake, or does not become tired, or does not lose its interest doing same thing or difficult thing again and again? What is the reason? What is the reason?
Because that's how it's programmed.
Yes, that is the thing. Good thing. Yes.
Good job.
Yes, good job, Muni. So actually, that is the power of a computer or any electronic device, is that it does not become tired or it does not do mistake because it is programmable, right? So we can write programs and we can store that programs inside the computer, like with a memory chip, okay, and we can run that program. So as long as the program will be running, okay, your computer will be doing that thing, right? So that is the main things, okay, because a computer is programmable, right? So now we are coming to topic 1, okay. So then what is computer science? Okay, do you have any idea what is computer science? Yes, Munim?
I think it's when scientists they see if computers can take over the world.
Yes, kind of. Anyone can participate, can volunteer. Madi? Okay, you, please. What is computer science? What do you understand by computer science so far? It's learn programming, okay? That thing, when you understand. So in general, okay, the people understand that the computer science means you will learn programming. That means if you study computer science, then people understand that you will learn programming, right? You know programming, you know, okay, how to do programming, right? So then also there is a misunderstanding that all computer scientists may not necessarily be a programmer. There are many other fields that in computer science and information technology area. We will talk that later, okay? So that main thing that is programming, right? Okay, the main, okay, essence of learning computer science is learning programming, right? So then my second topic is, what is programming? Do you have any idea what is programming?
Codes.
Yes, writing codes. Okay, good job, Munim. Then Mahdi has an idea. What is programming?
Writing codes to do a task.
Writing codes?
To do a specific task.
Yes, that's good, better thing. Writing codes to do or to perform some specific task, right? Okay, so the task is our problem, right? A task is a problem. So we will write some code, okay, to solve our problem, right? This is the thing of in computer science, okay, it's called programming. The main, that means that the main reason of learning programming is to learn how to solve a task or a problem using computer, right? By using a computer program, right? Okay, we will learn how to solve a problem or a task, right? Okay, so now I'm giving a hint what is called algorithm. An algorithm is a process or way to solve a problem. Okay. Yes, an algorithm is a way or process to solve a problem, task. Okay. So in our daily life, we face a lot of problems and we solve our problems, right? Some of our problems we solve manually, and some of our problems we solve using devices, right? For instance, when you in the morning when you come to office or school, we could walk manually. We could walk, right? But sometimes, most of the time, if it is too far, we do not walk, right? So we use another vehicle or another machine, right? Another device, so that our movement becomes faster. Like we use our car, we use our vehicle, right? Instead of walking. Okay?
Dishwasher.
Yes. Another example is using dishwasher, right? Every day we can manually wash our dishes, plates, glasses manually, but we use a machine, right? It's called dishwasher. It washes our dishes, dirty dishes, right? It makes clean and it has made our life easier, right? Okay. So then algorithm. So we will learn in this class actually the whole goal of this class is to learn how to write algorithm. Definitely you will understand what is an algorithm. You already knew that an algorithm is a process, step by step process to solve a problem, right? So then we will understand what is an algorithm, what are the properties of good algorithms, how to describe an algorithm, how to write an algorithm, and I will give you an example of an algorithm. Then by the end of this class, you will see what are the components of algorithm. Then you will be able to start your own algorithm. Okay. So are you getting interest to learn more? What is an algorithm? Mani? Still are you feeling sleepy or you want to learn? Thank you. You want to learn. Okay. So let's go to our next slide. Okay. So before I go to our next slide, so what is this on my hand? This is called a pointer, PowerPoint pointer. This is a device, right? So this device, it has some programs in it, right? So that when I click on the right button of this device, it will take me to the next slide. Okay? Without touching my computer, without touching my mouse, I can go to next slide. I can back to the previous slide, right? How it is possible?
Technology.
Yes. So what technology does this device has?
The motherboard.
See a small, it has motherboard, and basically it has a computer program, small program. It has some programs, right? So using that power of that programs, right, I am able to control something in this PowerPoint presentation slide in my computer. Okay. Then I don't need to touch my computer. Okay. So this is not a computer, but it is a device, and it has the power of device. Under the power of device, it has
Program.
a program. And everything, all electronic devices. This is an electronic device, right? It is called an electronic device, and for all electronic devices run under the power of
Program.
electricity.
Electricity.
Yes, right. Electricity is the heart, right?
Even a mouse.
Yes. In mouse we give battery, and or you hook up with
Needs
the
power.
power. So everything. So everything, but power is one thing, electricity, and it has computers. First thing we need power, and then the second thing we need computer programs, right? So in a proper combination of electric power, like computer programs and devices, the machines become powerful, more powerful, right? Sometimes more powerful than a human being, right? Okay. So next, start. So then, what is programming? You understand or not? You understand what we have already discussed. What is programming? A programming is a process.
Code.
Yeah, I'm writing code. A process. A program is a code. Program is a combination of some code, right? A programming in general is noun. Programming, that we would learn what is programming. Okay, programming is the learning process how to write computer program. So, right? So in order to learn computer programming, it needs two things, two skills. One is called algorithmic thinking. First one is called algorithmic thinking, and second of is the knowledge of programming language syntax. Okay. The first thing is that you need to think algorithmically. Okay. Yeah, that is called we will discuss that. What is algorithmic thinking? Algorithmic thinking is a thinking that maintains some steps following in a prescribed order. In a prescribed order, it follows some step with some order, with some accurate order. Okay, so without following order, you can if you do not follow the exact order, your thinking is not algorithmic. Okay, so if you are asked to, for instance, to add two numbers, like for instance 125 plus 25,
150.
150.
50.
Okay. How do you know that it is 150?
And I know math and I'm smart.
Yes, you are smart and you know math, because here there is an algorithm in order to add two numbers. You see, when I gave you first number 125, right? So you wrote in your mind 125, right? And then second, when I told you another number 25, right? And then you wrote 25 on the right alignment by making right alignment, right? Okay, you put 25 next 25 just before 25, right? So like for instance, if I gave you if I could explain here, for instance, when I gave you, so when I said for instance, when I said 125, then after that you wrote like this way. I said 125 first, and then in the second line you did not write 25 over here. You wrote 25 over here, right? By making right alignment. So that after that you made then 5 plus 5 equal to 10, then 4 plus 4 equal 2 plus 2 4, and plus 1 5, then 150, right? So here there is an algorithm you are following. So if you did not make your second number aligned with the first one, then your process would have a mistake, right? Then you would not get a correct result, right? So this is the algorithmic thinking or algorithmic process. Okay, and for instance, now when you use a calculator, or a computer. And if you use a calculator to add two numbers, for instance 125 and 25, it will automatically and within a few milliseconds it will calculate and it will solve your result, right? You calculate your two numbers, right? It will add up two numbers and it will give you a correct result 150. So that because the reason the calculator has some algorithms, some programs written on it, and those programs follow exact algorithm. Okay.
I couldn't understand. 125 or 25.
Yes. How do you add 125? Write down 125. On your
125
plus 25.
plus 25.
Yes.
150.
Yes. Okay. How do we get 150? How did you get 150?
Addition.
Okay. How did you make that addition? How did you make that addition? There is an algorithm. You are following an algorithm. Okay. A rule. Okay. That you are taught in your early age when you are an elementary student, right? How did you follow? How did you write that algorithm?
Like 125, then plus sign, then 25.
Okay, where did you write 25? That 25. After next to 1 or next to 2 or next to 1? Where did you write the 25? Up next to 12, right below the 12
No,
or
next
right
to
25?
25.
Okay, so why did you write next to 25?
This is maybe algorithmic
Yes, that is the algorithm. That is the rule.
rules. Yeah.
Yeah, that is the basic rule. That rule is called algorithm. Okay, the algorithm is that you have to fill up your first digit with a 0.
Yes.
Yes, so you wrote 125 plus 025, right?
Yes.
That means, but in general we do not write 0, right? This is you kept that 0 blank, but actually that is a 0. Electronics device calculator consider that empty space as a 0. So then you got 125 plus 25 equal to 25. Okay. So an algorithm, there is an algorithm here. You applied an algorithm. Okay. But without knowing that it is an algorithm. Right? Okay. And when we will write your computer program, okay, you will learn how to write algorithm, okay, and how to apply those algorithm using a computer programming language. Then
Java?
yes, like Java. Java is a good popular programming language. You in this class you will learn, okay, how to write an algorithm, and then after writing an algorithm you will be able to write a program. So this is an exact order of learning computer science, computer programming. Okay, this is an order. You have to start. Okay, you have to start with learning an algorithm first. After learning an algorithm, then you will write your code. But in general, nowadays, if you do a Google search, for instance, how to add two numbers, or how to find whether is a number is an even number or an odd number, you will get thousands of programs available online, complete programs. But it is not a good way for us to get a start with a program, find a program from online or anywhere, and start thinking learning computer programming, starting from by looking at following a program. We have to start from reverse order. First, we have to think algorithmically. Then we have to write our pseudocode. Okay, we will know in a minute what is pseudocode. Then we have to learn an algorithm. Then you have to convert your algorithm right in a computer program. Then actually in this class everybody has some algorithm knowledge, but you will increase your algorithmic knowledge, algorithmic thinking. Okay, you will increase your existing algorithmic thinking. Okay, and then you will see that there is a good relation between algorithmic thinking and learning computer programming. Okay, so if you can increase your algorithmic thinking, then you will be able to learn computer programming. Then you will get interest. Okay.
Standards.
Okay. Actually, learning a language syntax is easy part. If you learn to develop your algorithm correctly, then the next part, okay, to write a program is easy, really easy. Okay, but if you start with the wrong order, with an opposite order, okay, then it will be difficult. Okay, so you have to learn algorithm first. Okay, so that is why we should start computer programming with algorithmic development. Okay, we should start computer programming with algorithmic development. Okay. Okay, so then question is that how to learn computer science? We have to start computer science by learning algorithmic thinking. That means we have to know how computer works, how a computer works. Okay, we have to think, or either not only computer, how a device, how a machine works. We have to know that way, and we have to learn and process through that way. Okay, but many programmers, many people, they start learning programming in wrong way. They follow other people's program, and they think that if they follow other people's program, they will be able to learn programming. No, that is not a good way. So this is why in computer science programs, all students are required to start from learning algorithm and problem solving. So learning algorithm means a way of solving problems, right? Okay, so now we will begin our journey. Okay, sorry. Then now it's come. What is an algorithm? Let us review again. We already discussed. A set of logical steps. An algorithm is a set of logical steps to accomplish a specific task. Okay. So in other words, we can see a recipe of action. A recipe of action. Or in other way, we can say a way of describing a behavior. Or we can say a set of directions or instructions, okay, to perform a task. So there is a type over here, should be perform a task. Okay, so for instance, if I ask you, please, can you please tell me how can I go to downtown from here?
You can go to. We're gonna
Okay, can you please help me? How can I go to downtown?
go on your phone and then search up downtown.
Okay, yes. If I go to my phone and if I can type in how to, like if I open Google app, right? And if I write how to go to downtown, it will show me some directions, right? Those directions are the steps of the algorithm that helps me to solve my problem. What is my problem? How to go to downtown. That was my problem, right? And when I use Google app, Google Directions app or Google Maps app, and when I give my current location and destination location, and it will give me some steps. I have to follow the step. Okay, go like 500 feet, then turn right, then go 200 miles, then turn left, then go 10 miles, then exit 227. Okay, right? Those are the steps. Those are the steps of an algorithm, right? For solving my problem. What was my problem again?
You don't know how to go to downtown.
Yes. Okay, I did not know how to go to downtown. So if I ask someone else, or a machine, or a GPS, it will give me some steps. Okay, to go how to go to downtown. Okay, those steps are the steps of the algorithm. Okay, and then in combination of all of the steps is a complete algorithm, right? So now the question is that, can I follow all of the steps randomly? Can I follow any of the steps randomly?
No.
No?
You have to follow the direction
Yeah, I have to follow the order,
in order. Yes.
right? I have to follow the first step first direction first. Then without completing the first step, I cannot go to the next step, right? Okay. So this is why an algorithm should be, okay, should have some direction. Direction needs to be complete, and the direction needs to be, I have to follow the direction in order. Okay. So an algorithm, yes,
Step by step.
step by step. Okay. So all algorithm contains two things. One is called input data, and another some instruction, some data and some instruction. Okay. When I asked you, recall that when I asked you to add two numbers, 125 and 25, right?
Yeah.
Okay. I gave you data, two data. What are those data?
125 and 25.
Okay. Those are data. Data, right? Numbers, data. Okay. And I gave you some instructions, or you added some instructions in order to get the sum of, like, what are the instructions?
Like
Plus sign and equal sign.
Equal sign.
Okay.
Division sign.
But here you used plus sign
And equal sign.
and equal sign. Okay.
The division sign was not needed, right?
Another place you can use.
Yeah. So then what was your result? 150. That was a kind of data.
Yeah.
That was another kind of data, right?
And
So
output.
and that is called output, right? So as an input, we gave some kind of data. So in all computer programs, okay, one in an algorithm, okay, so we give some input, okay, an algorithm is a step, okay, that perform on those.
Look at the screen.
Moni, look at please. Give attention, please.
Look at, very nice. Look at the screen. Look at.
Okay. So in all algorithm, we give some input. Okay. Then we give some instructions. Okay. An algorithm. The instruction is called algorithm, right? A set of instruction is called an algorithm, and then it gives us an output. Okay. So in general, we give input. That means I said 100. What is the sum of 125 and 25? That 125 and the second number 25. Those two numbers are input.
What's the output?
150.
Output is result.
Result. Output is the result. Okay. So in all algorithms works in this way. It takes some data, okay, and it do some operations on those data, and it gives
Some
an expected result, right? Some output, right? Okay. For instance, this is a recipe algorithm. Okay, how to make a chocolate chip cookies. Okay, so yeah, can you please see the water data here or ingredients?
Eggs.
Okay, it has some eggs, it has 2 eggs.
Milk.
Okay, it has some milk. Okay, it has 2 1/4, yes, flour, sugar,
Chocolate chip.
okay,
Salt,
okay.
vanilla,
Okay, so you see that these data are provided with some specific amount or size or count, right? So you cannot put any number of eggs. You cannot put any amount of salt, right? You cannot put any amount of sugar. Okay, after that it has some instructions, that the steps, right? Okay, what is the first instruction? What is the first instruction?
Preheat oven to 375 degrees.
Fahrenheit, maybe, or centigrade, maybe. Okay, then combine. The second step is combine flour, salt, baking soda in, okay,
In the bowl.
bowl and mix aside. Set mixer aside. Okay, so then what is the last step over here?
And it's
What is the last
Bake.
step?
Okay.
8 to 10 minutes.
bake 8 to 10 minutes.
Okay, so now if I do this instruction, all of these instructions, but in a different order or in a random order, will I get a good cookie?
No.
Chocolate?
No,
No, right? What is the reason?
Because
don't work.
You did not follow the
I did not follow the instructions.
you didn't follow the algorithm.
Yes, that is the things. I did not follow the
algorithm.
algorithmic. Okay, because I did not think algorithmically. I did not think. If I do not think algorithmically, then my problem
It's
will not be solved. Right? So this is why while doing algorithmic computer program, we need to use some data, and we need to do some operations on data by following some steps in order, right? Okay, that's good. Okay, so in algorithm, in computer programming learning, you need to learn another thing. Okay, that is very important. This is difficult but very important thing. It is called abstraction. Abstraction is an idea. Okay, abstraction is an idea. So when you read a book or a journal paper or a dissertation, you see maybe for a 10 pages journal paper, you will see a small paragraph of abstraction, right? In the abstract, it will say very precisely, shortly the output of the study, right?
Don't listen.
Output of the study, right? But it will not tell in detail. So abstraction means that it will give you a general idea, okay, but it will hide your detail, hide the implementation details.
So it only gives important stuff?
Yes, it is important. Okay, so for instance, in daily life, we use abstraction a lot. For instance, when we start our vehicle, car, okay, we put the key in, and then we do a right click, and then if his vehicle is good, then it starts up, right? So even we do not know how the machine and how the ignition system works in order to start the engine, right? It is not necessary for us to know that, right? Is it necessary for us to know how the engine works?
No, but for the person who made the car. But for the person who made the car.
What is that?
It's the person who made the car fixes cars, you know.
But
It's like
it's not.
the person who fixes computers, you know.
The person, yes. That if I want to become a mechanic, right?
It's a computer.
Yes, if I want to be a mechanic, okay, if I want to fix a car, then I need to know how the ignition system works, right? But in order to drive my car, I don't need to know that. That part is as hidden or abstract to me. Okay?
If it wasn't abstraction, then if you didn't know how to start a car, you'd like first put the key in slowly. But then if it has obstruction, it's like saying put the key in.
Yes. So the process of abstraction, the abstraction process has made our life easy. Okay? Through abstraction, we concentrate on one thing, and we ignore many things. Okay? So while we run our car, we drive our car, okay. So once this car is started, we never think how his engine is working. We do not think that, oh, if engine stops, then what will happen, right? We don't think that, right? What we think, we hold our steering, okay. We keep our leg on a brake or the gas button, so we can concentrate on what is in front of us. Okay, we don't concentrate how the engine is working, right? So abstraction process has made our driving is easier. So if you think about, if I have to every second, if I have to think how the engine is working, if I have to remember how the engine is working, how the gas system or ignition system is working in every second, then it will be difficult for us, right? We may be misguided, right? Okay, distracted. Okay, so but the abstraction system, that it has made our life easy. I don't need to think about that. Okay, so we, when our car starts, so without a rare case, if the engine does not become something wrong, then we believe that it will be running, and we will be just driving. Okay, so in our general life, we use abstraction a lot, especially, okay. So but in computer, in mathematics, we use abstraction, right? For instance, when you give plus sign, when you use a calculator to add 125 plus 25, we use the plus sign, right? But we don't know how the plus sign is working. Is it our headache to learn how the plus sign is working, how the equal sign is working? That is not our headache. Our headache, we see that whether this calculator is giving me right result, accurate result, right? How do we know that it is giving me an accurate result? If I add 2 plus 2, a known number, two known numbers, and if I get a known result, then it's that we think that it is giving a correct answer, right? So then if we give 2 plus 2, if it gives me 5, then we think, oh, there is something wrong in it. Then we do not become dependent on it, right? We think that then this calculator has problem, right? So that means the abstraction is an idea. Okay, sometimes you will see in learning programming, we will avoid some complicated thing, abstract thing, okay, because we don't need to know that. Okay, sometimes we will see that, sometimes we will use some abstract term. Okay, so then it is not your headache to concentrate on those abstract terms. Okay, this is why we discuss abstraction. Okay, it is a really critical thing. In real life, we use a lot of abstraction thing. For instance, in mathematics, we write 10 to the power 3. What it means 10 to the power 3? You understand? 10 times 10 times 10.
10 with 2 additional zeros?
Yes, that 1000, right? So if someone asks me, how much is this laptop? Is this MacBook? You say, okay, so do you say that it is 10 to the power 3 dollars?
No.
We know that 10 to the power 3 equal to 1000, right? Instead, easily we say that it is $1000, right? 10 to the power 3 equal to 1000 in mathematics, but in mathematics, while writing in expression, shortcut expression, we write 10 to the power 3, right? But while we speak in English, we do not say this laptop cost me 10 to the power $3, right? You understand? No? 10 to the power 3. What is 10 to the power 3?
1000.
Okay, so 10 to the power 3 is an abstract format. Okay? In mathematics, while writing an expression, we use sometimes square root, x square.
Shortcut.
Yes, shortcut way. Abstract means shortcut way. But in general, many times we do not use abstract word in our daily speaking English, right? We do not say this. If this cost $1000, we say 1000. It cost $1000 or 10 hundreds, right? 10 hundreds. But we do not say it takes 10 to the power $3, right? Okay, that is an example of abstraction. Okay, There is other abstraction, like we say vehicle. Is there any
Spelling mistake.
Okay, there is a spelling mistake. Vehicle abstraction. Okay, yeah. Okay, vehicle. Okay, vehicle in general vehicle. Okay, this is an abstract word. So abstract means it has no actually real thing. It is a name, or in it's called as common noun. Okay, we say in order to, when we say vehicle, we mean, what do we mean by a vehicle? Either a car or a bus or a truck.
Or any kind of transportation stuff.
Yes.
So actually, we cannot see the word vehicle anywhere.
Yes.
That's why this is abstract.
Yes. Abstract is a concept or
Something
idea.
is concept or idea you cannot see.
Okay. For instance, if I say, please bring me a fruit. Okay, so then you will bring either a banana or an apple or a pineapple, okay, or a mango
Or tomato.
or a tomato.
But what is fruit?
What is fruit?
Tomato is a fruit.
What
Yes, tomato is a fruit, kind of fruit. That kind, everything in this world has a kind.
Only tomato is not a fruit. Only mango is not a fruit.
There are many other fruits.
Many other fruits.
Or you can take or even eggs.
Okay, so in general, mango fruit
Is a
is a
concept.
concept. Okay, an abstract concept. Okay, and a mango is a concrete object of that type, that concept, right? Okay. So in general, in our daily life, we use abstraction a lot. Do you need a break? Okay. So now we have to think why abstraction is needed in algorithm.
Because, like, if a computer doesn't follow the rules correctly, then it can take you to a different task that you didn't want.
First in here, if we say how to go to downtown, okay, how to go to downtown, or how to go to Kennesaw State University or Clayton State University from Atlanta, this is an abstraction. It's a shortcut of your problem, right? And then,
Non-obstruction, it would be like the road.
yeah, then the one implementation of this abstraction is that you will begin and you will start some steps, right? Following the step, get on I-75, then exit 75, take exit 234, and turn left, go there, go there, go there. We use in algorithm development. For instance, here the abstraction, how to go to, for instance, Clayton State University's IT department from Atlanta.
Okay.
In shortcut. Okay, so that means the abstract idea is here. So how it says, how can we go to Clayton State University IT department? Okay, so in shortcut it says abstraction. In abstract, this one implementation of this abstraction is our problem is defined in abstract way, or our solution sometimes is defined in abstract way. So it's if I tell you that this is a way to go to the Clayton State University from downtown Atlanta downtown, right? So there could be multiple ways, multiple directions to go to Clayton State University from one place to another place, right? This may be one way. This could be implementation, one kind of implementation of this abstract solution, right? For instance, gate 1, go to the I-75, then hit south, then take exit, for instance 234, and turn left. Okay, and then this is the process, right? This is one kind of implementation. Okay, there may be another kind of implementation, right? We will accept this implementation as long as we can go to our destination point, right? But there may be another better way to do that. Different way. There may be other different ways. Those different way could be better than this or worse than this.
Or similar.
Okay. So, but we don't. It is not our headache at this moment. Okay. People and computer science always try do the research. Okay, in order to make algorithm better and better and better. Okay, so when you write an algorithm, okay, so then don't hesitate and don't be worried that my algorithm is perfect. Is this the best algorithm? No, you don't need to think about that. Okay, so you need to start with something, with a naive algorithm, so that your concentration will be, initial concentration will be in a way that you have to solve this problem, no matter if it is a best way or it is the best way. You have to think about to solve your problem in a better way. Otherwise, you will try to make your algorithm better and better. For instance, when you write an algorithm today, and if you revisit this algorithm, review this algorithm next time, you may find some mistakes in your algorithm, and then you will find a better way to solve this problem, or you will find a better way to make your algorithm better. For instance, look at this code. This is an algorithm. How to do hair shampoo. Do you find any mistake in this algorithm, Munim?
What is wrong with this algorithm?
Do you find any wrong in this algorithm?
Need to repeat. And get to keep doing it over.
Munim, do you find any mistakes, any wrong here?
Repeat.
Yes. What is the reason of repeat? Is the mistake over here?
Is that you get to keep doing it over and over again?
Yes. It does not say when you have to stop it. It will say keep doing it all the way, right?
Keep doing.
But do we do that? We do one time or two times, right? We do shampoo one time or two times, right? Okay. So the mistake over here is the last one, repeat, right? So that means it has not any ending point, right? For all algorithm, you should have an ending point. You see this algorithm is an end.
Output data.
Yeah, so that you can stop at a certain time, right? Okay. So if you do not, then that if you do not end, that means at some point you will pass your result. You will pass your destination, right? You will overpass your destination there. So that all algorithms should be constant. Okay, so that is actually all algorithms have some properties in order to be a good or perfect algorithm. Okay, so what are the properties of a good algorithm? Is a good algorithms are precise, okay, and it should be unambiguous.
Ambiguous means
confusing.
Unambiguous means no confusion, like straight, clear cut.
Okay,
Complete.
and then it should be complete. Look at it should be correct, and it should be simple as possible, and it should contain labels of abstraction. That is the thing. Okay, so now let us revisit our previous algorithm, like this algorithm. So let us first, what is the first criteria? It should be precise.
Sure.
It should be unambiguous.
No
okay.
conflict.
So let us see whether this algorithm is unambiguous.
What does that mean?
Unambiguous. Do you have the correct direction in it. So it says get one I-75 heading south. So if you tell you get on I-75 without telling heading south or north, would it be a good algorithm?
No.
No. There is ambiguous. So I am getting an I-75. So, okay, but I-75 has definitely at least two directions, either south or north, or east or west. Right? We know here that I-75 has two directions, south and north. Right? So your algorithm and your direction should precisely tell us, okay, that whether you have to take south direction or north direction. Right? Instead of telling that, your algorithm is not correct. Your algorithm is not unambiguous, right? Okay. So, is it a complete? It looks a complete. Complete means it will start and end. Then it will give you a destination.
Yeah.
Okay.
This is complete.
It seems complete. Okay, it seems complete, but it seems complete. But so how do we know that it's complete? It says park in the front of IT department. That it said if we go follow this way, I got your destination. Okay. Okay. So then another is this simple?
Yes.
It's pretty simple.
Basically.
Yeah, basically simple. And what is the last one? It contains a level of abstraction.
Yes.
Does it contain level of abstraction?
Yeah.
Where it is level of abstraction?
Go to I-75
Begin.
Okay.
Parking front at the IT department.
Begin. Exit. Turn left. Turn right.
Okay. So okay, so there are some hidden stuff over here, right? Hidden step over here, because it never says that stop on a red signal. Do you see?
But that's common sense.
Yes, common sense. Okay,
Yeah.
that is common sense. Okay,
But
so we are.
But if you say this is not written here, I have to stop on the.
I don't need to stop on red
So
signal.
it's not in the recipe. It's not in the abstraction. So I don't want to follow it.
Yes.
No.
No, right?
Then they
So
don't have common sense.
yes, that is the common sense, but computer does not have any sense.
Secret instruction.
Yes.
Instruction.
Yes, you have a common sense, right? You have some common sense, but computer does not have any common sense. You have to put that sense in your steps when you will go to implement your algorithm. When you go to write your code, then you have to give a stop sign, right? Okay. Okay, then it's good thing. We are almost away. Okay, we're almost at the end. Okay, and then we are, okay. So how to describe an algorithm? We can describe an algorithm in natural language, definitely in English language. We can describe an algorithm is a picture or flowcharts.
Oh, picture won't work as much because the picture it doesn't have any words that describe it.
Yes. Even sometimes if you do not give any word, you say if you give arrow, right, left, forward, left, forward, then it's
That is flowchart.
yes, flowchart. It will give you a direction,
Yeah.
right? Then when map, when you see, so we'll see that later, okay? And then there are multiple ways. These are the three common ways of describing an algorithm. Describing a step by step in natural language. For instance, if I ask you how to go to downtown, you will tell me that go this way for 10 minutes, then turn left, then go 2 minutes, and then go straight 5 minutes. These are the steps, like in natural English, right? But you can describe this by drawing a picture. By drawing an arrow, using arrow, like give an arrow, then left arrow, then right arrow. You will put 10 minutes. I will understand that I have to go 10 minutes. Map. Okay. And there is another good way of writing pseudocode.
Pseudo what?
Pseudo means, what is the meaning of pseudo? Fake. Fake code or likely code, like a computer code. Okay. So pseudocode is the good way to describe algorithm. Okay, is quickly. Pseudocode is the middle between an algorithm and a programming language. Some pseudocodes look like programs. Okay, and some pseudocodes look like a natural language description. Pseudocode is the middle of
In between.
in between natural language and computer language.
Middle between of right and wrong.
No, it should be right. It needs to be
What
right.
is a fake?
No, fake means your code are fake. Your codes, your instructions are fake. We'll see in a minute. Okay. So in this course you will learn how to write pseudocodes. Okay. Okay. Now let's go. Okay. Now our journey begins. Happy everybody?
Yes.
Okay.
It's 4
Write
o'clock.
an algorithm to enter your first and last names and display your full name.